The qualitative analysis of for the interference. Now we are going to know this. We discussed about the coherent sources in earlier classes and earlier videos. We discussed about the coherent sources when by doing this Slit experiment. Slit experiment means by doing the sum of the slits, did the experiment by the coherent sources and to observe the formation of bright bands and dark bands on the screen. Let's see, this is a Slit experiment diagram. So from that S, the source S, from the S, the wavefront has a incident on the slit which is having that this is S1 slit, S2, two slits is there, S1 and S2. These are the secondary wavefronts. This is the primary wavefront, which means the wavefront moving through the slits and this S1 S2 behaves the secondary sources of the secondary wavelets. Here in case of the due to the phase difference, this is the first positive phase, negative phase, positive phase, negative phase, positive phase, negative phase, means whenever the light is passing through this, then here we give the some of the different colors for that. The bright color, this red color with for the positive phase and dark color with the negative phase. Then whenever the due to the phase difference is there, whenever light is passing, means moving forward direction, this is positive, negative, positive, negative, positive, negative, like this. So here it is that the slits are emerged from this place. This is positive edge, this is also positive edge and ended that. Then positive phase, negative phase, whenever it is moving that, and instant at the center, always at the center of the screen, the bright band has formed because of there is no phase difference between the slits, and whenever this slits to the screen, there is no phase difference or path difference. There is no path difference between the screen to the slit. So that's why always at the center of the screen, bright band will be formed. Due to the formation of phase change, means due to the change of phase, constructive and destructive interference will occur due to the in this wavefronts. So that's why some of the bright band and dark band, means whenever here is the two same phase, means positive phase. So that's why here is that bright band has formed. And so that here in case of one of the dark band, means the opposite phases are different phases of formed. So that's why they to interfere on one another. So that's why here dark band will be formed. So like this, the dark bands and bright bands are formed due to the Slit experiment. Whenever the source has taken at a distance of the two slits are having the distance of small d, and the big screen, that is a XY screen, is at the distance of capital D, distance of capital D. So that's why at the center of the screen, bright band has formed because of there is no any path difference between the slits to the screen. So that's why always at the center we can see the bright band only. Due to the destructive and constructive interference, bright bands and dark bands are formed. In this case of the schematic diagram to know this, fringe width. Fringe width means a bright fringe or a dark fringe, means width between the bright band and dark band. We are going to study the expressions mathematical form. According to this mathematical form, let's see, as be the source, the light emitted from the source and instant is passing through the slits are S1 and S2 at a distance of small d, at a distance of small d, and at the capital distance of capital D is screen placed, that is xx dash, considered xx dash with the screen, and at the center of the center bright band, CBB means the center bright band is formed beside the center bright band. Always beside the bright band, dark band will be formed. After the dark band, bright band will be formed. So here it is that at the center the distance will be capital D. From the point, a point P taken at the on the screen is P. The distance from the point to the P is Y, which is making an angle with the center of the, center of the slits. The point P making an angle with the center between the slits is theta. Always this will be also theta. So here is that from this diagram we can find out that simply from according to the geometrical method, from geometrically we can write that geometrically from S1 S2 N from triangle S1 S2n. We are doing in simple method. So S1 S2n sin theta is equal to we know that sin theta is equal to opposite by hypotenuse. This is the theta and this will be the opposite, means S2n by adjacent hypotenuse will be S1 S2, that is equal to, this is delta x by, this will be the d, means, so that's why we can write that the path difference delta x is equal to d sin theta. The path difference delta x is equal to, we can write that path difference delta x is equal to d sin theta. But from the d sin theta is also we can write that from the equation, that is delta x is equal to, here is that from the slits either S1 or S2 from the center of the, between the two slits we can write that triangle from this is center O and this is a point considered. Then the between this triangle, whenever which is the centers of this point P making an angle theta with the between the center of the slits, between the center of the slit is theta. So from that sin theta is equal to, this is that, consider it's a M, point M, consider point OMP. From OMP sin theta is equal to opposite will be OP by hypotenuse will be MP. MP is nothing but which is equal to OM, because of the slits are very small distance which is having coherent sources, so that's why we can say that the slits and difference will be the very small for small angles. So that's why we are considering that OP MP is equal to MO. MP, that is MP is similarly equal to MO, so that's why we are writing that OP is equal to Y, small y, by MP is equal to capital D, because of MO is also capital D, means the distance between the slit to the screens are capital D. From this equation we can write that delta x is equal to D sin theta is equal to small y by D. This is the equation for the delta x is equal to yd or dy. We can write that yd by d. If we write that dy, then somebody thinks like that there is a change in difference in the length. So that's why we are writing yd by d. So that's why this is the path difference between this will be the S2n, means the difference between the two slits. In this case also we can write, means delta x is equal to, already we know that delta x is equal to, here that delta x is equal to that S2p minus S1p, S2p minus S1p. So from that case we can write that S2p minus S1p is equal to y small d by capital D. This is the path difference. Between the two ways moving from the slits, S2 from the S2 and S1, these two are this is the path difference. S2p minus S1p is equal to yd by d. Again this formula also can be done by using the Pythagoras principle of the two, by using the two slits also, means the triangle we can write this is the distance and this is the d by 2, and by doing this y minus d by 2 y plus d by 2, by applying the Pythagoras theorem also we can do the same thing. But this is the easiest method to do, there is nothing to worry about it, this is the easiest method. So right, again the geometrically we know that from the triangle S1 S2n we are doing sin theta is equal to S2n by SS2, because of opposite by hypotenuse. S2n be the opposite and hypotenuse will be the S1 S2. So delta x by d from this equation. Path difference delta is equal to d sin theta, we know that from this. So again from triangle OMP, this is OMP. From the triangle OMP it is making an angle theta with the center of the slit. So that's the slit. So that's why we are writing that triangle OMP sin theta is equal to OP by MP. The difference between the for small angles we can write that for small angles we can write that is delta x is equal to S2p minus S1p. Means here that we are writing that the S1p distance and S2p distance which is near to MO, because of there is a distance between the slits are very small, because of they are the coherent sources. Already we studied about the coherent sources, they must be near to each other, closer to each other, then only the light ray will be, instead bright bands and dark bands will be, coherent sources will be formed. So that's why here that by doing this, sin theta is equal to OP by MP, then we can get Y by D, because of OP is equal to, from O to P distance is Y, and MP which is similarly equal to MO. So that's why here we are writing the capital D. From this we are substituting this equation in the above. Delta x is equal to d sin theta, delta x is equal to yd by capital D. We can write that, but we know that delta x is equal to S2p minus S1p, then only we can get this length, path difference, this path difference. So that's why the path difference delta x is equal to S2p minus S1p, S2p minus S1p is equal to yd by small d. By taking these values, we can observe the path difference, observe the dark band and bright band path difference between the two any path differences, we can find it out by observing. So the path difference delta x is equal to S2p minus S1p is equal to yd by d, means the distance between path difference between, by using this formula we can find out the distance of dark or bright fringes or dark bands or bright bands from the center of the screen, we can find out. So for in the case 1, the first one is case 1, for a bright band, for a bright band, from the qualitative analysis of interference, we did the equation for the bright band. The path difference will be delta x is equal to 2n into lambda by 2, 2n into lambda by 2, that is the equation for the bright band, 2n into lambda by 2. By using this formula, if we substitute those, delta x is equal to, already we have that yd by small d. From that equation we can write that here the 2n into lambda by 2 means we can write that this is n lambda, this is a n lambda. So that here that we can write that S1 delta x is equal to yd by d. So y into small d by capital D, that is equal to n lambda. For nth bright band means wherever n is taken as the number of bright bands, then we can write that whenever the capital D and small d taken this side, then y nth bright band. Y means the distance from the center. By using this formula we can get that y means here the distance of bright or dark bands from the center of the screen to that point. Another, whatever the nth bright band means, if in case of this is the first bright band and this is the second bright band, then means n value be the n is equal to 1, 2, 3 up to so on. So right there we can write that n into lambda capital D by small d, n lambda capital D by small d, means here that we can write that where n is equal to 1, 2, 3 up to so on, we can write that means n number of bands. Here we can write that n1 be the first bright band, and n2 be the second bright band, and like so on. So on, we can write that the different bright bands which are formed from the center of this the first bright band and this the second bright band, means if we substitute n is equal to 1, we can get that the distance from the center of the first bright band is lambda d by d. And if in case of second, if it's applied that number 2, n is equal to second bright band, means n is equal to here 1, 2 means here we can get the distance from the center to the second bright band. Like that we can get by using the equation, that is y nth of b is equal to n lambda d, n into lambda d by capital D, where n is the number of bright fringes. Here we are taking that y nth distance, nth bright band, the distance of nth bright band, we can get that n by n of b is equal to n into lambda d by d, where n is equal to 1, 2, 3 up to so on. We can get by using this formula we can find out the distance from the distance of bright bands, number of bright bands from the center of the screen. So this is the equation. This equation or this expression gives the distance, of nth bright band, from center of screen. Center of a screen. Nth brightband from the center of a screen. Next, the case 2. Case 2 for the dark band. We know that for dark band, we already derived an equation from a qualitative analysis of interference, that is delta x is equal to 2n plus 1 into lambda by 2. 2n plus 1 into lambda by 2. If we substitute the same equation, means here we have that equation delta x is equal to yd by d, then we can get that. From the experiment we did that the delta x is equal to y by d. If we substitute this equation, we compare with the two equations, then we can get a yd by capital D is equal to 2n plus 1 into lambda by 2. If we take in this capital D and small d this side, then we can get y nth of a dark band. Y nth of a dark band, then we can get that 2n plus 1 into lambda into capital D by 2 into small d. Lambda into capital D by 2 into small d. This equation gives that. This equation means we have that this expression gives the distance of nth dark band from center of screen. From center of screen means if in case of n1 be the first bright band, first dark band, sorry, and second dB be the distance from the center to the distance, then we can get that equation. Though whenever the two equations we can take, then that where n1 is equal to first dark band and n2 be the second dark band and so on. We can get the values of the distance from the center of the screen to the dark bands, and this is the distance between the from center to the bright bands. By using these equations we can take. So next we are going to know this, what is the distance, fringe width. Fringe width is denoted with a beta. Fringe width is nothing but the distance between the two successive bright bands or fringes. Here the fringes is considered as a bands is called as a fringes. So here it is the distance between two successive bright bands. It is called as a fringes or dark bands. Is called a fringe width. Beta. Fringe width means here the any distance between the two successive, means here is the bright band. What is the distance between the two bright bands or two dark bands? The distance between the fringe width means the distance between the two bright bands or two dark bands is considered as a fringe width. The distance between two successive bright bands means bright fringes or dark fringes is considered. So for one fringe means nth fringe. For nth bright fringe I am taking that bright fringe y nth of bright fringe is we have the equation for bright fringe n lambda d by d. This is the for nth fringe. For n plus 1th fringe bright fringe, then y n plus 1 into bright fringe, that is n plus 1 into lambda d by d. This will be this. whenever by doing this, when the total what is the distance between the beta is equal to the distance between the two fringes, two bright or two dark fringes, then if I subtract then yn plus 1 minus yn plus 1 into b minus yn of b, we can get that n plus 1 into lambda d by small d minus n lambda d by d. If we subtracted means whenever we did this one inside, we multiplied inside, then n lambda d by d plus 1 is there, lambda d by d, we are separately writing the denominator, so then minus n lambda d by d. Then from that the plus minus can be cancelled, then we can get that some beta is equal to lambda capital D by d, lambda capital D by d. Here is that from the equation beta is equal to lambda d by small d, we can write that the fringe width is directly proportional to the distance between the screen to the slits, directly proportional to the distance between the slits to the screen, and also proportionally to the wavelength. So what is the wavelength is there, this is directly proportional to the wavelength, and inversely proportional to the distance between the slits. Means here the fringe width is directly proportional to the distance between the slits to the screen. Means whenever if the screen distance will be increases, between the slits to the screen distance will be increases, then its fringe width also increases. Means the distance between the fringe width also increases. Then also and is directly proportional to the wavelength. Wavelength of the means the rays are moving, in that case it depends on the wavelength also, and the distance between the inversely proportional to the slits, distance between the slits S1 to the S2. So here it is that we can write that beta is equal to lambda d is proportional by small d, means fringe width is directly proportional to the wavelength and the distance between the screen and slits, and inversely proportional to the small d means distance between the slits, we can write. So this is about the Young slit experiment and the conditions for the dark band and bright band and the fringe width.